Hi everyone, and welcome to this YouTube channel. My name is Penny, and this is Penny's Coding Bits. This channel is dedicated to bring you weekly bite-sized videos with practical solutions for your everyday data analytical challenges. And this video is going to go through how to come up with the ideal combination of investments for your desired risk level. And we are going to go through this in Python as well as MATLAB. And the link to this code book is included in the description box below. If you want to pull that up and follow along, feel free. I'll give you a minute to do that. So, before we begin, we need to define three functions. The first is the portfolio return, which is based on the individual returns of each investment in your portfolio, as well as their weights that's held in your portfolio holdings. The next is the portfolio volatility, which measures the extent the portfolio's value goes up or down. And the next is the minimize volatility function. This is a helper function which would be used later on in our optimization code. And now that we have these three defined, we will be ready to load in our dataset. Now in Python, we have this special library called yfinance, which contains the historical investment prices that's traded on open market on Yahoo Finance. So we can use this library to load in the historical adjusted close price for our three stocks here between January 1st, 2020 and January 1st, 2021. And once we do that, we can calculate the percentage change of the stock prices between the dates that we have pulled in. As well, we need to define the number of assets that we're dealing with here. Although that's kind of obvious, the answer is 3, but we need to give it a variable name so that we can use this in our optimization later on. We would also need some constraints. So the weights that we hold for each investment should add up to 1. And no weight of any investment should fall below 0. So they should be between 0 and 1. So with all that defined, we would be ready to go into our optimization function. So this code chunk right here is basically our optimization function. And what this does is it pulls 100 target returns between the minimum portfolio average return and the maximum portfolio average return. And there's equal spacing between each target return pulled. And for each target return, this for loop would come up with the investment weights for each investment that would achieve that return, but with minimum volatility. So that's where the minimum volatility that we have defined above is being used. And once we have this pairing of target return versus the weights of investment that minimizes volatility while achieving those returns, we can plot this relationship into a visual. And that looks like this efficient frontier right here. And once we have this curve, we can operationalize it by going backwards. So when we optimize, we went from pulling the target returns and come up with the portfolio weights that would achieve those returns that minimizes volatility of the portfolio. Now we have the pairing. We can say, given this volatility level, this is the maximum return that we can expect. So this is what this function does right here. Once we have all of this defined, we can have a user input defined here so that you can enter a decimal number. And the system would return the weights that's associated with that risk level. So now we have a system that reads in your desired volatility level and outputs the amount of your money that you should be invested in each of these stocks. Now, we can have a look at how this is working in MATLAB. And for those of you who don't have MATLAB installed, I will have a link down below that takes you to a page where you can install it. So this is MATLAB. And to import this stock price data, you would simply go to import data and it would bring you to another screen. And you can click your stock data CSV file and say open. So you can have a preview there, and then if it looks good, you can just import. I'm not going to do it here because I already have it in our main window. So the code to come up with the efficient frontier, as well as operationalizing the entry of the volatility level and outputting the desired combination of investment weights, is here. We have the convert prices to returns function. This is similar to the calculating returns function in Python. And we need to set up the portfolio optimization problem here and estimate the efficient frontier. And we have a estimate frontier function here. So this is part of the financial toolbox in MATLAB. There's a lot of toolboxes in MATLAB that just makes the code a lot shorter. So this one line basically is our entire optimization function that's right here. So you can see how efficient it is. So once we have the frontier, we can plot the efficient frontier into a visual and use a user input command so that you can enter your desired volatility level and come up with the portfolio weights that achieves that volatility level while maximizing return. So why don't I just give that a try here? So you can see this is the efficient frontier plot in MATLAB, and as well it has this user entry line that's right here. So I'll just put 0.029 and it gives me the desired allocation of portfolio weights that I should be investing in each stock. So that's a quick and dirty tutorial of how to come up with the ideal combination of stocks to achieve a volatility level while maximizing return. If you would rather have a text version of this tutorial, I have included a link to a Substack page that contains the same information I had just gone through. I also host a monthly CodeChat at 5 p.m. Eastern Time on the last Friday of every month. So for November, that will be November 24th, which is the Friday of next week. If you're interested in joining a group of coding enthusiasts live on a meeting setting, please visit the meeting link at the time of the meeting. If you would rather have a reminder email sent to you with the meeting information, there is also a sign-up page that you could go to input your email address. Thank you for joining me today. I'll see you in the next video.